Hello, dear 8th graders. How are you guys? I hope everything is fine with you. Let's talk about the vertex form of a quadratic equation. It is our last class. Attention here to understand everything about that. We learned a few classes ago about the standard form. The standard form, it is as we do in linear equations, is ax squared plus bx plus c. We see three numbers, two coefficient and one constant. Okay, we have a quadratic coefficient, we have a linear coefficient, and we have the constant, the number without variable. I think you remember all these names, yes? Right now, let me talk with you how do we figure out and find the vertex form of a quadratic equation. Mister, what is a quadratic form, vertex form of a quadratic equation? Guys, the vertex form is easiest ever from the other ones. How, mister? Can you prove to us? Yes. Guys, the vertex form, we can easily find the vertex. Remember, x of symmetry and y intersect. We can easily find out this. How, mister? Look at our presentation here, guys. Here, I have my quadratic equation, my vertex form of quadratic equation. A is the number outside here, x minus h squared plus k. And as I told you guys, we want the opposite. I told you in the classroom, I think you remember, I need first, the x of symmetry is the value h, but the opposite of h. If what is negative, I want the positive and vice versa. Remember? And k is the y-intercept. The y-intercept, guys, you see here is just itself, just k. Oh, mister, it's easy. Yes, I told you. For example here, y equals x plus 4 squared minus 2. My x of symmetry, x equals negative 4, the opposite of positive 4. And my y-intercept, it is negative 2. Oh, mister, so easy. Yes, I told you guys, it's very easy. Here, we made some examples here using the formation. And remember, guys, it's so easy to complete the table here. The opposite for positive 2, negative 2. The x of symmetry is in negative 2. And positive 7 here. Great. Put this number here, this ordered pair in the middle row. And complete the table with the next neighbors, negative 3, negative 4, and negative 1 and 0. Just solve the equation here, and we got some results over there. And whoop, we have our graphic. Oh, mister, y opens down. Look, this negative here. This negative means to us opens down. Great, guys. And remember, guys, domain, our input, we can pick any number as I want. My output, I cannot choose. I can have the output as all kind of numbers less than or equal to 7. It's very easy, guys, to figure out this one. Let's go ahead. Here, as you notice, guys, we hope we'll have more problems. I will try to solve one here. I'll have transformation. Let's talk about transformation. What is transformation, mister? We have the most simple quadratic equation. It is x squared. Remember, guys, opens up. X squared. And the x of symmetry is exactly 0. It's more normal here, as you can see here in black. This is the normal quadratic equation. We have a name for this equation. This is the parent function. Oh, functions have parents? Yes, they have. Just kidding, guys. But we call this a parent function because all other graphics came from that. All other equation, we can return to something like that to be sure we understand this point, okay? A transformation, what is a transformation? Transformation is a change to the size or position of a figure, okay? A transformation, what are we doing? We have our parent function here. We are moving of size. We're moving for position, okay? This is the way, the thing we need to figure out. And here, when we need to analyze the situation, here, look, this equation, y equals x plus 2. I need the opposite, negative 2. And the ordered pair here is 0. I don't have any number here, is 0. Negative 2 and 0. Here is my new equation. I graph it. And you tell me, what was the transformation? The transformation was left 2 times. I move my graphic 2 times to the left. Okay? Let's go ahead here, guys. Let me explain to you some more things. Oh, mister, let's solve more. Yes, let's do it. Here, let me pick here number 10. I will pick number 10. Why, mister? Because number 10 is number 10. Great, guys. Here, I have negative 4. What is the opposite for negative 4? Oh, positive 4, mister. X equals 4. Great. I just write here, guys, directly to be the middle row. It's 4, positive. And what is the y-intercept? The y-intercept is 1. And here's my y-intercept, 4 and 1. Pick neighbors to the 4. I will pick 3, 2, oops, yes, less than and greater than 5 and 6. And solve our equation for y. Solve for y, guys. My equation here is negative x. Instead to negative x, I put the number. Negative minus 4 squared plus 1. Here's our original equation. Instead to use x, I will use right now example number 3. 3 minus 4 is negative 1. Negative 1 squared is 1. But I have a negative outside. It's negative 1. Negative 1 plus 1, 0. And as we know, it's symmetric. Here is 0 also. And when it is 2 right now, let's think about now 2. 2 minus 4, negative 2. Negative 2 squared, it is 4. I have a negative outside, it's negative 4. Negative 4 plus 1, negative 3. And as we know, it's symmetric. Here is the information. Let's plot 4, 1, or turning point, or vertex. Great, 4 for x, 1, 2, 3, 4, and 1 up. Here. Great. Here is my turning point, my vertex. And the other one is mister. Oh, the other one is so easy, guys. It's 3, 0 here. And 5, 0 here. Symmetric. And the other one, 2 is negative 3, negative 1, negative 2, negative 3 here. And, okay, 2, negative 3. And 6 is negative 3 also. Here, they're symmetric. Here is my graphic, guys. Let's draw right now our smooth parabola. A smooth parabola. Oops. Let's draw this smooth parabola here. Oh, mister is not good. Okay, I know. Oh, very bad here. Let's move. Oh, it's ours. And right now. Okay. Guys, not be perfect, okay? The transformation. First, look for the parent function. Where is it? The parent function is here. What's happened with our function? It flipped. It flipped. The first thing happens. Great. There are equation here, as you notice, we flip it. We have a new one here. Flip it, and I move to the right how many times? 4 right, right. I move 4 times, and I move up 1 time. Great, guys. Here is the way to do when you talk about transformation. You tell me what's going on. Great. Let's go, guys. We have more problems here. I will solve this for you guys. The number 12. Why, mister? Because we have a special thing here. Number 12, guys. Here, the opposite for negative 3, it is positive 3. Let me just change here. It's positive 3, just 3. And the other one is negative 2. Here is my ordered pair. Let me draw here the graph. 3, 1, 2, 3, negative 2. 1, 2, here. Great. My graphic is over here. Start here at least. Right now, let's solve. It is a negative a half x minus 3 squared minus 2. Instead to write, okay, my equation is negative a half x, I don't write x here, negative 3 squared minus 2. Instead, to use this number, I get two numbers less than 2 and 1, and 4 and 5. Great, let's use here 1. If I got a 1, guys, it is my solution. 1 minus 3 is 2. 2 squared, 4. Oh, negative 2 squared is 4. 4 divided by negative half, or 4 divided by negative 2, or a half, negative half of 4. It is negative 2. Negative 2 plus negative 2, it's negative 4. Negative 4 here, negative 4 here. They're symmetric. Great. Let's go here, guys, to understand the next one. Oh, it's negative 4. Are you sure? Let me check again. Oh, sorry, guys. 2 minus 3 is 1. Negative 1. Negative 1 is square is 1. A half. Negative a half of 1, it's negative a half. Negative a half minus 2, it's 1 and a half. Negative 1 and a half. For real? No, we are adding. It's negative 2 and a half. Oh, mister, negative 2 and a half. Great, now makes sense. Great, it's negative 2 and a half here. And the next one. Mister, can I write this decimal form? Yes. I just write here in fraction, mixed number, or decimal. It's up to you. Great. Next one, mister. Let's use 5. Okay. 5 minus 3, it is 2. 2 squared, 4. 4 times negative half, it's negative 2. Negative 2 minus 2, it's negative 4. Negative 4. Now it makes sense. Great. Let's plot the graph here, the other ones. 2 and negative 2 halves. 2, here's negative 2, negative 2 halves. This is kind of here. Great, it's a halfway for this one. And here also is symmetric, it's here also here. And the other one, when it's 1 is negative 4. When it was 1, negative 2, negative 3, negative 4, here. Here and here. They are symmetric. Great, guys. And let's graph right now. Here I have a different way for a graphic, guys. Very interesting. What's happened here, mister? We have 4 things happen here. We have a compression of our graphic. Compression. Because I multiply by a half. It's like you divide by a half. We have a compression for its size. Okay, we had a compressed fraction right now, compressed graph. If I compare with the parent fraction, parent function graph, or a wider, why? Because it's wider than the other one. Great. Flip it. I flip it from the parent function, and I move right 3 times and down 2 times. Great. Guys, I think you understand this point, but let's go ahead here to finish our class. Let's put it together. What is it, mister? Let's remember here all the things we learned this class. H is the horizontal shift. Okay, horizontal shift. Okay, and K is vertical. I think you understand what's going on here. H, I move horizontal, and K, vertical. And here, what does it mean? The shift is up, left first, or horizontal first. Left or right. Great, the negatives is right, the positive is left. And the vertical positives is up and down. If A is negative, the function is reflected, guys, like a mirror. Where? Where is the mirror, mister, for when you have this kind of situation? Across the x-axis. Here's my mirror. Where is it? Great. When the absolute value of A is greater than 1, represent a vertical stretch. What does it mean, mister? We stretch our parent function. We're comparing for our parent function. We have a stretch over here. When 0 less than a less than 1, we have a compression. Compression. Great. Compression. Very good, guys. This information is very important for use in future. Great. Let's do a transformation here, guys, to understand. We read this information and we convert it in an equation. I know my original equation, it is y equals x. I have an a here, we'll have this past. X plus or less something, okay? We need to figure out is square and plus or less something outside. Let's be sure here. In this case here, translate 2 units right. When I move right, the shift is -2. I move right. Great. Plus 0. Don't have nothing here. And my equation is x minus 2 squared. Great. Very easy, guys. We translate all this information to an equation. Very easy to do. Great, guys. We finish here our video. I think you understand all these steps, understand how to do it. Okay? See you next class. Bye bye.